The second half of section 7.4 talks about complex fractions. And we're going to talk about them, and there are a couple different ways that you can tackle these types of problems. And some teachers swear by one way or another, but I want to show you how complex fractions are really just a combination of the things that we've already done. I think of complex fractions as a three-part problem. Part 1, you got x over 5 plus 4. Do that addition to get that to just one fraction. Part 2, you've got 8 plus 1 over x. Add those together, get that down to just one fraction. Then part 3 is you've got the fraction from the top divided by the fraction by the bottom. Do keep, change, flip with that division problem. So I'm looking at your assignment, and it looks like the one complex fraction on your assignment is similar to this, so we will do this one problem. All right, so part 1, I've got x over 5 plus 4. That 4 is currently over 1. So the denominator on the left has a 5. The one on the right needs a 5. So we stick a 5 on the top and the bottom. Our common denominator is 5. 1 times 5 is 5. On the top, we've got x plus 4 times 5 is 20. So there's the result of simplifying the top of that complex fraction. Now we've got 8 plus 1 over x. What does the first fraction need? It needs the x so that they both have x. You could say the other one needs a 1, but times 1 doesn't change anything, so yeah. Our common denominator is x. On the top, we have 8x plus 1. So that's the result of the bottom. Now what we have is a division problem. Yellow divided by green. So we're going to keep the first fraction the same, change the sign to multiply, flip the second fraction. And this just becomes x times x plus 20, because why would we multiply that together if it's nicely factored out, over 5 times 8x plus 1. And that would be our final answer. Now, there are other ways to do complex fractions. There's a way that you can do this all in just one step, one-ish step. I say one step, but in one-ish steps. But from my experience, learning that method is like learning another thing that you have to do. This method is going to work for you every time because you know how to add fractions together now. You know how to divide fractions, so just break this up into those pieces and you can get to the answer. Also on worksheet 7 is the beginning of solving equations. So up until now, we haven't had equal sign in the original problem. But if you look at worksheet 7, number 6 and number 7, it says solve the equation, and there's a fraction on the left and a fraction on the right. We're going to do number 2 together. It's the most similar to the problem in your assignment. When you have fraction equals fraction, that is the only time that you are allowed to cross multiply. Some of you get this cross multiply thing in your head, and so then you try to cross multiply all the time. The only time you can cross multiply is when you have fraction equals fraction. So this is a perfect case for multiply or for cross multiplying. You should put parentheses around any numerator or denominator that has addition or subtraction in it. So when we cross multiply, I've got x minus 2 times x minus 1 equals 6 times the quantity x minus 2. What do you think we need to do on each side? We need to distribute, multiply it out. So we've got x times x is x squared, negative 1x, negative 2x plus 2, and 6x minus 12. Now, we've been doing a lot of factoring in this chapter, and we're going to have to factor this as well. We need to get one side equal to 0 so that we can factor and solve. So we've got x squared minus 9x plus 14 equals 0. We are looking for two numbers that multiply to give us 14. I'm guessing that's going to be 2 and 7. Isn't that like the only thing besides 14 and 1? Those two numbers have to add up to negative 9. So they both need to be negative. Okay. So what are my solutions? Positive 2 and positive 7. There are two possible solutions. Now, the number one rule in math is you can't divide by 0. So, if we had gotten x equals 1, what happens if you plug 1 in right there? You'd have 0, and that wouldn't work, so x equals 1 would be an extraneous solution. Now, in this particular problem, we didn't get x equals 1. We got x equals 2 and x equals 7. Check both of those answers to see would either one give us a 0 on the bottom of one of our original fractions. So 2 minus 1 is not 0, 7 minus 1 is not 0, so both of these solutions are totally fine. But take a moment and check those solutions to see if one of them maybe would give you a 0 on the bottom. If it does, cross it off. Okay, I'm going to tell you right now to cross off, or at least don't do number 7 on worksheet 7. So if you're working on worksheet 7, you can skip problem number 7. Skip problem number 7 on worksheet 7.